The paper of the day is Hekaton, SQL Server's memory optimized OLTP engine. Hekaton is the new database engine optimized for memory resident data and OLTP workloads. Hekaton is fully integrated into SQL Server. It is not a separate system. To take advantage of Hekaton, a user simply declares a table memory optimized. Hekaton tables are fully transactional and durable and accessed using the T-SQL in the same way as a regular SQL Server table. A query can reference both Hekaton tables and regular tables, and a transaction can update data in both types of tables. T-SQL stored procedures that reference only Hekaton tables can be compiled into machine code for further performance improvements. The engine is designed for high concurrency. To achieve this, it uses only latch-free data structures and a new optimistic multi-version concurrency control technique. This paper gives an overview of the design of the Hekaton engine and reports some experimental results. The Hekaton consists of three major components. The Hekaton storage engine manages user data and indexes. It provides transactional operations on tables of records, hash and range indexes on tables, and base mechanisms for storage, checkpointing, recovery, and high availability. The Hekaton compiler takes an abstract tree representation of a T-SQL stored procedure, includes the queries within it, plus table and index metadata, and compiles the procedure into native code designed to execute against tables and indexes managed by the Hekaton storage engine. The Hekaton runtime system is a relatively small component that provides integration with SQL Server resources and serves as a common library of additional functionality needed by compiled stored procedures. So as we can see in this figure, on the high level, there's a SQL components and Hekaton. And on the Hekaton side, you have compiler, runtime, storage engine. On the SQL component side, you have security, metadata, query optimizer, query processor, and storage. And then there's a kind of arrow going both ways. You have metadata, query optimizer, query interrupt, transactions, high availability, storage, and lock. Here are the key contributions of Hekaton paper. Hekaton is designed for high levels of concurrency but does not rely on partitioning to achieve this. Any thread can access any row in a table without acquiring latches or locks, and this is really the key. The engine uses latch-free data structures to avoid physical interference among threads and a new optimistic multi-version concurrency control technique to avoid interference among transactions.